How CPUs work. Every time you open an app, load a web page, or start a game, a small chip inside your computer begins working almost instantly. This chip is the CPU, or Central Processing Unit. It is often described as the brain of the computer because it controls how instructions are executed and how data moves through the system. While modern computers contain many specialized components, the CPU still plays a central role in coordinating everything. From launching programs to performing calculations, the CPU is constantly processing instructions at incredible speed. So today we are going to walk through how CPUs actually work and how this tiny piece of hardware manages to run the software we rely on every day. Chapter 1. What a CPU is. A CPU, or Central Processing Unit, is the primary processor responsible for executing instructions in a computer. Software programs are ultimately just sequences of instructions, telling the computer what actions to perform. The CPU reads those instructions, interprets them, and carries them out. These instructions might involve mathematical calculations, moving data between memory locations, or controlling other parts of the system. Although modern computers contain many specialized processors, the CPU remains responsible for handling general-purpose tasks. Chapter 2. Instructions and programs. At the lowest level, software programs are made up of machine instructions. These instructions are written in binary, the language computers use internally. Each instruction tells the CPU to perform a specific operation. For example, one instruction might add two numbers together. Another instruction might move data from memory into a register inside the CPU. Programs contain long sequences of these instructions, and the CPU processes them one step at a time. Chapter 3. The fetch, decode, execute cycle. The CPU follows a repeating process known as the fetch, decode, execute cycle. First, the CPU fetches the next instruction from memory. Next, it decodes the instruction to determine what operation is required. Finally, it executes the instruction by performing the necessary calculation or data movement. This cycle repeats continuously while the computer is running. Modern CPUs can perform billions of these cycles every second. Chapter 4. Registers and internal storage. Inside the CPU are small storage locations called registers. Registers temporarily hold data that the CPU is currently working with. Because registers are located directly inside the processor, they can be accessed extremely quickly. This makes them ideal for storing values used during calculations or instruction execution. Although registers are very fast, they are also very limited in size. As a result, the CPU frequently moves data between registers and the system's main memory. Chapter 5. The arithmetic logic unit. One of the key components of a CPU is the arithmetic logic unit, often called the ALU. The ALU performs mathematical and logical operations. These operations include addition, subtraction, comparisons, and bitwise calculations. Whenever a program performs a calculation, the CPU sends the numbers involved to the ALU. The ALU processes the operation and returns the result to the CPU for further instructions. Chapter 6. Control units. Another important component of the CPU is the control unit. The control unit manages how instructions move through the processor. It coordinates when data is fetched from memory and when operations are performed. In simple terms, the control unit directs the flow of activity inside the CPU. Without it, the processor would have no way to organize the sequence of instructions it must execute. Chapter 7. Clock speed and timing. CPUs operate according to a clock signal that controls timing within the processor. This clock determines how quickly instructions can be processed. Clock speed is often measured in gigahertz, which represents billions of cycles per second. A higher clock speed generally allows a CPU to perform more operations in the same amount of time. However, performance also depends on other factors, such as architecture and the number of cores. Chapter 8. Multi-core processors. Modern CPUs often contain multiple cores within a single chip. Each core functions like an independent processor capable of executing its own instructions. This allows the system to perform multiple tasks simultaneously. For example, one core might handle a web browser while another manages background processes. Multi-core processors improve performance when software is designed to distribute work across several cores. Chapter 9: CPU Caches. To reduce delays when accessing data, CPUs use small high-speed memory areas called caches. Caches store frequently used data close to the processor. This allows the CPU to retrieve that data more quickly than if it had to access main system memory every time. There are usually several levels of cache, each with different sizes and speeds. By keeping commonly used information nearby, caches help the CPU operate more efficiently. To wrap up, a CPU is the central processor responsible for executing instructions in a computer. Programs consist of sequences of instructions that the CPU processes through the fetch, decode, execute cycle. Registers and caches provide fast storage for frequently used data, while the arithmetic logic unit performs calculations. The control unit manages the flow of instructions, and the processor's clock determines how quickly operations occur. Modern CPUs often include multiple cores to allow several tasks to run simultaneously. Together, these components allow the CPU to coordinate the operations that keep a computer running. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.